All right, here we are, 4.6a. So we have a system of equations. And one of the things you need to realize is this particular system is a pretty simple one. But we're going to use determinants that we learned in the last section and that we're going to continue to learn in this section in order to solve for x and y. Now, using matrices, using determinants, all these new words that you're hearing, is just another way to solve for x and y when you're given an equation like that. Okay, so what I need you to do is look in the middle of page 381, and I will put the picture of that on here. Okay, so there's the picture, and this is, it's called Kramer's rule. Now, let's make this a little bigger for right now. What we've got here is pretty much what I have up here. We've got a number times x plus a number times y equals c there. And we have the same thing here. So we have two equations here, but instead of a 2 and a 4, we have an A and an A and a B and a B for the 3 and the 5. All right, so there's a way in order to find out what x is and what y is. Now notice what they did is they gave us the answer for x, or the how to find x, believe it or not, by writing this. Okay, a division problem. And they gave us the way to find y by doing this, which was basically another division problem. Okay, the hard part is, or the question is, what is d of x? What is d? What is this d of y? So we need to know, and these two d's are the same. So we need to find a d of x, and a d of y. So let me give you what the d of x is. D of x is c1, b1, c2, b2 in a 2 by 2 determinant. Okay, d of y equals a1, c1, a2, c2, and then d equals, I'm just copying this down from what they give you in the book because I want you to at least kind of follow what's going on here and not just zone out on me. Okay, so now we can look at the original equation up here of come on pencil, a1x plus b1y equals c1, and a2x, and I will explain what's going on here. Okay, so let's get this picture out of the way here. All right, so what I've got, let me get my arrow, is this is my system of equations. Okay, just like this one that I had right here. Okay, it's just like that. So I have a number, a number, a number, a number, a number, a number for A, B, and C. Okay, so what we're doing then is, in order to get this d of x here so we can find x, we do this matrix. We start plugging in. So the C1 goes there, the B1 goes there, the C2 goes there, and the B2. Okay, we don't even do anything with A's with our d of x. We'll wait for our A's until we go to the y. And then when we do the d, we leave the C's out. Okay, I know this is really, really confusing what's going on here. So let's go ahead and use this equation here that we have right here and follow this procedure and see what we come up with. So let's go with blue. Dx equals, it says C1. C1 is the last number of the top equation, which is a 4. Okay. B1 is the first number, is the number in front of the y. Here, what number is that? It is a -3. And then we've got C2, which is the last number of the second equation. So that's going to be a 3. And then we've got a B2, which is this number, which is a 5. Okay, so now we'll do a dy. That's going to be that. So we've got a 1, which is this. So it's 2. We've got C1, which is going to be a 4. We've got A2, which is going to be the other 4 in the bottom row, and a C2. Then we've got D, and D is going to be A1, which is the first number on the top row. B1 is the first or the second number on the top row. A2 is the first number on the bottom row, and B2 is the second number on the bottom row. So there are my 3 sets of determinants that I need to solve now. So for my dx, I'm going to do 4 times 5 minus -3 times 3. Okay. For dy, I'm going to do 2 times 3 minus 4 times 4. And the d, I've got 2 times 5 minus -3 times 4. Okay, so we're going to figure out what we have there in the black. And we've got 20 plus 9, 6 minus 16, and 10 plus 12. So at this point, our dx is right here, our dy is here, and our d is here. This says that x equals dx 29 over d, which is 22. And our y equals dy, which is -10, over d, which is 22. So that's your x value, and that's your y value, 29 over 22, and then this can reduce to -5 over 11. All right, so notice, this is why we use matrices. When you go to this original problem that we had here, right here, sure, we can find numbers to multiply this top by in order to make this top one a -4 so that we can add these and get 0 and then solve for y and do the system of equations that we've done previously. But we end up with these ridiculous fractions, and it is easier to use Kramer's rule in order to find this, even though it initially looks really, really confusing. In the end, it's really not too bad. So let's try a couple more examples here. And we will do those in 4.6b.